Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Creating and Solving Quadratic Equations in One Variable. Classwork, opening exercise. When it says exercise, you do it. Pause the video, do this, come back, see how you did. Okay, here we go. The length of a rectangle is 5 inches more than twice its number. The width is 4 inches less than the same number. So I would always, when I'm doing a geometry type problem, draw a diagram. A rectangle, the length is 5 inches more than twice a number. Well, a number, we can call that any variable we want. And I will use, a number, use the letter n. So 5 inches more than. Now remember back when you were learning how to go from a sentence into a mathematical expression or equation, the word more than means to add, and it means to read from right to left. So I would say twice a number, 2n plus 5 is how you'd write 5 more than twice a number. Okay, so that's the length. I put it in the wrong place, so let's put it right here. So there is my 2n plus 5, okay, the length. The width is 4 inches less than. Less than means subtract and read it right to left. The same number n. So that would be n minus 4. Okay, so there's our diagram label. Sketch a diagram of the situation and find the unknown number. Okay. And it says the perimeter is 44 inches. So this plus that equals perimeter. So perimeter's equation is P equals 2 times the length plus 2 times the width. So write a formula, substitute in the givens. Perimeter is 44. The length is 2n plus 5. The width is n minus 4. See how easy that is? P, 44. The 2 is 2 times the length, and the length was this value here. And plus 2, and the W is n minus 4. Okay, now we're going to simplify and solve. We want to get n's by themselves, and we want to get it down to 1n. So the first thing we're going to do is distribute. So we're going to have 44 equals 2 times 2n is 4n. 2 times 5 is 10. Plus, distribute 2n minus 2 times 4, which is 8. Okay, combine like terms. 4n and 2n, and the 10 and the negative 8 are like terms. So 44 equals 4n plus 2n, 6n. Plus 10 minus 8 is 2. Okay, now we're moving stuff over to the other side. So we've simplified as much as we can on the right. We have a linear expression on the right, and I'm going to use SADMAP. So I'm going to subtract 2 from both sides first. And 44 minus 2 is 42. Equals 6n plus 0, or just 6n. Now this is multiplication, and the inverse of multiplication is division, so we will divide both sides by 6. And n is going to equal 42 divided by 6, which is 7. And it is in inches, so it's 7 inches. Okay, now that we've found the answer, we need to check this. So 2 times 7 plus 5 is our length, which is 14 plus 5, which is 19 inches. So this is 19 inches, and this is 19 inches. And then the n was 7, so 7 minus 4 is 3. So this is 3 inches, and this is 3 inches. So 19 plus 19 is 38, plus 3 is 41, plus 3 is 44, and it checks. Example 1. The length of a rectangle, okay, so here is a rectangle. The length of a rectangle is 5 inches more than twice the number. More than is plus, read it right to left. Twice a number plus 5. The width is 4 inches less than is minus, read it right to left, the same number, n minus 4. If the area of the rectangle is 15 inches squared, find the unknown number. So we write a formula. Area of a rectangle is length times width. So area, let me redo that. So area equals, actually, we can start substituting. Area is 15 equals the length, 2n plus 5, times the width, n minus 4. Okay, this is FOIL, so I'm going to multiply first terms. So I'm going to get 15 equals 2n times n is 2n squared. 2n times a negative 4 is negative 8n. 5 times n is a positive 5n. And 5 times a negative 4 is negative 20. Okay. So that is going to simplify to, let's see, let's use black. 15 equals 2n squared, combine middle terms, negative 8n plus 5n is negative 3n minus 20. In order to solve a quadratic, we want it equal to 0. So I'm going to subtract 15 from both sides. Zero equals 2n squared minus 3n minus 35. Look for a greatest common factor. There aren't any. Okay, just needed to clean that up a little there, get that out of the way. All right, so since there are no greatest common factors, we will have to factor this. So I'm going to use my Beats method. So A equals 2, B equals negative 3, and C equals negative 35. We're looking for factors of A times C, which is negative 70, that add up to negative 3. In order for it to be negative, the bigger number has to be negative, and the smaller number has to be positive, because a positive times a negative is negative. So it's 1 times a negative 70, and add those, you get negative 69. It's not negative 3, so I keep going. 2 times negative 35 is a negative 23 or negative 33 sum. 3 will not go, 4 will not go, 5 times negative 1, 4, negative 14, that's a difference of 8, almost, not quite. 6 won't go, 7 times negative 10, and there is our difference of 3. There's our minus 3. 7 minus 10 is negative 3. So now this is going to be 0 equals n plus 7, n minus 10. We multiplied the 2 over here, so I have to divide it back out. If it does not reduce, it moves to our coefficient. So our equation is now going to be 0 equals the quantity 2n plus 7 times n minus 5. 10 divided by 2. Okay, so remember the zero product property from lesson 4. So therefore, if to make this equal to 0, we would say 2n plus 7 equals 0, 2n equals negative 7, n equals negative 7 halves. There's one answer. And in this case, if I set n minus 5 equal to 0, then n would have to be 5. So n equals 5. We are talking about length. It cannot be negative. So this is an extraneous solution. My answer is n equals 5. So then I'm going to check that. 2 times 5 plus 5. 5 times 2 is 10, plus 5 is 15. So this is 15. And 5 minus 4 minus 4. 5 minus 4 is 1. 15 times 1 is 15 inches squared. It checks. Okay, example 2 says a picture has a height that is 4/3 its width. It is to be enlarged so that the ratio of the height to width remains the same, but the area is 192 square inches. What are the dimensions of the enlargement? Okay, so there's a couple ways we can do this. We could say that this is its width, and the length would equal 4/3 its width. But then we're dealing with fractions, and so what we can do is set up a ratio. Since we have 4/3, that is a ratio or a proportion. The height is 4:3, so if the height's 4, the width was 3. 1 1/3 of 3 is 4. Okay, so in order to avoid using a fraction, so if I made this 3 times that size, and I made this 3 times that size, then these cancel and I have 3 and 4. Okay, so let me get all this mess out of here. And I will call that 3 and this 4. It's to be enlarged so that the ratio of the height to the width remains the same, but the area is 192 inches squared. Well, the area of this right now is 12 inches squared. We want to enlarge it so it's 192, so we want to scale it up by a factor that we don't know, and we're going to call that x. So area equals, and we're talking about width and height, so it's width times height. So the area is 192, and the width is 3x, we'll call it, because we're scaling it. 3 times some number. The width is 3x, and the height will be 4x. So I write 44. Try that again. 4x. All right, so 192 equals 3 times 4, which is 12. X times x is x squared. We want to solve for this unknown variable. So I divide both sides by 12. And 12 goes into 19 once with a remainder of 7. And 12 will go into 72 6 times. So 192 divided by 12 is 16. Equals x squared. In order to solve a squared equation, we do the inverse. We want to take the square root of the variable and the constant. So x squared square root is simply x, and the square root of 16 is plus or minus 4. But we're talking about length here, so I'm going to ignore the minus answer. So the answer is x equals 4. So that means, since this is an x and this is an x, it means that this is 3 times 4, or 12, and this is 4 times 4, or 16. So it is a new dimension of 12 by 16. And if I take 12 times 16, okay, going a little too quickly there. 1 times 2, 1 times 1, 2, 9, 1, and it checks. Okay, exercises. That means you do them. Pause the video, see if you can do numbers 1 and 2, and then unpause the video and come back and see how you did. Okay, so here we go. Solve the following problems. Be sure to indicate if a solution is to be rejected based on the contextual situation. The length of a rectangle is 4 centimeters more than 3 times its width. Okay. So I have a rectangle. The length is 4 centimeters more than, that's plus, and we read it right to left, 3 times its width. Okay, the length is, so this is the, let me do this. Let's do it this way. Okay, so 3 times its width plus 4. And the area and the width is just simply W. The length of the rectangle is 3 times its width plus 4. 4 more than 3 times its width. Okay. If the area of the rectangle is 15 centimeters squared, find its width. All right, so area equals length times width. Area, plug in the givens, 15. Length, 3W plus 4. Width, simply W. And so now we simplify by distributing. W times 3W is 3W squared plus 4 times W, or W times 4 is 4W. Okay, now we have a quadratic. This is the quadratic term. This is the linear term, but we have a 15 over here. We need it to equal 0, so we subtract 15 and get our constant over here. So this is going to leave us with 0 equals 3W squared plus 4W minus 15. Okay, I'm just going to continue down here and then I'll erase it after. All right, so we have a 3, we have a 4, we have a 15. 3 will go into 15, but 3 will not go into 4. We do not have any greatest common factor of the 3 terms, so I'm going to use my beats method where I multiply A times C. So A equals 3, B equals 4. I struggle with writing a 4. It just keeps snapping and closing that gap. And C equals negative 15. All right, so I want factors of A times C, which is negative 45, 3 times negative 15, and I want them to add up to 4, positive. So the bigger number is positive, and the smaller number is negative. So negative 1 times 45 adds up to 44. That is not 4. Negative 2 doesn't work. 3 does. 3 goes into 4 once, and 15 5 times. So it's negative 3 times 15 is negative 45. 15 minus 3 is 12. That is not 4. Keep going. 4 will not work. 5 will. 5 times 9 is 45, and 9 minus 5 is 4. So then I have W minus 5 and W plus 9 equals 0. Don't forget that we multiplied by A, so we need to divide by A. If it doesn't divide, it goes out in front. So we have 3W minus 5 times W plus 9 divided by 3, which is 3. Okay. If I go back up here, the opposite of what's here makes this 0. So W would equal positive 5/3, or W would equal the opposite of this, which is negative 3. Remember that this is length. This is what's called an extraneous solution. A length cannot be negative, so the answer is 5/3, or 1 2/3. Number 2, the ratio of length and width of a rectangle. Let me just steal this. Okay. The ratio of the length to width in a rectangle is 2 to 3. The length is 2, the width is 3, so I'm going to rotate this back to here, and we'll use this. All right, so 3x, 2x. Whenever you have a ratio, you just say 3 times something and 2 times something. Find the length of the rectangle when the area is 150 inches squared. So area equals length times width. The area is 150. The length is 3x. And the width is 2x. Okay, so 150 equals 3 times 2, x times x. And we have 150 equals 6x squared. Now, since we don't have a linear term, then we can do this a couple of different ways. We could bring this 150 over and make it our constant. Okay, or we could, let's see if this would work. I want to solve for x by divide by 6 both sides. Then I get x squared equals 6 times 2 is 12 with a remainder of 3, 30, that's 25. Okay, so whenever we have one term over here, you don't have to make this a quadratic error and bring over the constant and treat it that way. This is quicker. And then once we do this, we just simply take the square root of both sides. And so x equals plus or minus 5. But we're talking about length, so it can't be negative. So there's our answer. Pretty simple. 5 times 3 is 15. 5 times 2 is 10. 15 times 10 is 150. It checks. Always read the question when you're done. Find the length. The length is 15 inches. Oh, I'm sorry. That's not the length. That's the width. The answer is 10 inches. Haha, there. Okay, number 3. I drew a trapezoid because that's what this is about. One base of a trapezoid is 4 inches more than twice the length of the second base. Okay, so remember height is here. This vertical line that forms a right angle. The height of the trapezoid is 2 inches less than the second base. One base of a trapezoid is 4 inches more than, that's plus, and read it right to left, twice the length of the second base. So this is the longer one, so I'll call that twice the length of the second base. So 2x plus 4, and this is x. The height of the trapezoid is 2 inches less than the second base. X minus 2. Okay, so there they are. One base is an unknown x. The other base is 2 times that plus 4, and the height is that base minus 2. All right, so the area of a trapezoid is 1/2 base 1 plus base 2 times its height. So since they've already written that formula, I'm just going to substitute it in. And it says, if the area of the trapezoid is 4 inches squared, find the dimensions of the trapezoid. So area is 4. Okay, base 1 is simply x plus base 2, which is 2x plus 4, times the height. So this might get a little confusing here. Let me use brackets instead. So this should be a bracket here. Let's do it that way. Okay. So now I'm going to simplify. Combine these. X plus 2x is 3x plus 4 times x minus 2. That's our height. And then we need to distribute this 1/2 through here first. So 4 equals 1/2 times 3 is 3/2 plus 1/2 of 4, which is 2. times x minus 2. Okay, now we're going to distribute. So 4 equals x times 3 halves x is 3 halves x squared. 3 halves x times a negative 2 would be negative. The 2's cancel, and it's 3. Okay, so here, let me do this in color. So the first thing I did was here, and that gave me this. And then I'm going to do 3 halves x times negative 2, and the 2's cancel. Positive times a negative is negative. The numerator's left behind, so that's 3. Minus 3. And then I'm going to do the inner, which is 2x plus 2x. And then I'm going to do the last, which is positive times a negative, 2 times 2. Combine like terms. And we get 4 equals 3 halves x squared plus 2x minus 7. Okay, I was just looking at this and I caught something, so let me just erase this. Let's get rid of that there. When I multiplied 3 halves x times x, I get 3 halves x squared. That's correct. But when I multiply 3 halves x times a negative 2, it's a negative 3x. And then the inner is 2 times x, which is 2x, and 2 times negative 2 is negative 4. So I made a mistake there. So now the proper equation is 4 equals 3 halves x squared minus x minus 4, because minus 3x plus 2x is negative x. And I want to get this equal to 0, so I subtract 4 from both sides, and I get 0 equals 3 halves x squared minus x minus 8. I don't like fractions, so I'm going to multiply everything by 2. 2 times 0 is 0. 2 times 3 halves is 3. 2 times a negative x is negative 2x, and 2 times a negative 8 is negative 16. Now I'm going to use my beats method to do a equals 3, b equals negative 2, c equals negative 16, factors of a times c, which is 9. No, it's not. 3 times 6 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. Positive times a negative is negative. I'm looking for factors of negative 48 that add up to negative 2. 1 times negative 48 adds up to negative 47. 2 times negative 24 adds up to negative 22. 3 times negative 16 adds up to negative 13. 4 times negative 12 adds up to negative 8. 5 will not work. 6 times negative 8 is a negative 48, and that is a difference of negative 2. So my 0 is going to equal x plus 6, x minus 8. Don't forget to divide by 3. And 0 is going to equal x plus 2 times 3x minus 8. So what makes this 0? So x has to equal negative 2, or x equals 8/3. We're talking about length, so this is my extraneous solution, and my answer is 8/3. Now I'll go back and read the question. What are they asking for? What is the width W? Oh, I'm sorry, I'm looking at the wrong question because I went down so far. It says, if the area of the trapezoid is 4, find the dimensions of the trapezoid. Okay, so 8/3. So now the dimensions of the trapezoid, let me erase this. This is x. So that is 8/3. This is 8/3 times 2, which is 16/3 plus 4. And 4 is 12/3. So that's going to equal 28/3, which is 9 1/3. Okay, and the height is 8/3 minus 2. Well, 8/3 is 2 2/3, so the height is 2/3. Okay, so 2/3 height, 8/3 base 1, and 9 1/3 the other base. Or 8/3 is base 2, and 9 1/3 is base 1. Number 4, a garden measuring 12 meters by 16 meters is to have a pedestrian pathway that is W meters wide, installed all the way around it. So we have a rectangle. So it's 12 by 16. And it has to have a pedestrian pathway that is W meters wide, installed all the way around it, increasing the total area to 285 meters squared. So in other words, we are coming out like this. And a pathway that we have an undetermined width is going to go all the way around it, where this is the width of the path. Okay, so it says, what's the width W of the pathway? Okay, so we don't know how wide this path is. So this is the width right here, W. But it's also the width of this one over here, W. So if you are adding W, so let's look at this 12 meters from here to here. If I'm adding a W here and a W here, that's 2W. The length is now, this was 12 meters. So now this whole thing is 12 plus 2W. And this whole thing, this part right here is 16, but we're adding a W and we're adding a W. So that's now 16 plus 2W. So that's how big the rectangle is going to be of the garden with a path that we don't know the width of. So we know the area is 285 meters squared. So area equals length times width, 285 equals the length, 16 plus 2W. And let me change that. I like having my linear term in standard form, so I'm just going to reverse that. 2W plus 16 means the same thing. I just like that better. And then instead of 12 plus 2W, I'm going to put 2W plus 12. All right, so 285 equals, and I will do my distribution. 2 times 2, W times W. Two W times 12 is 24W. Sixteen times 2W is 32W. And 16 times 12 is... Hey Siri, what's 16 times 12?
16 times 12 is 192.
Thank you. Okay, so save a little time there. Phone helps. So 285 equals 4W squared plus 24W plus 32W plus 192. Simplify. 285 equals 4. 285 equals 4W squared plus, combine my middle terms, 24 plus 32 is 66. 3 times 5, 6, 56. W plus 192. Wow, big numbers. In order to solve a quadratic, we need to set it equal to 0, so I'm going to subtract 285 from both sides. And we're going to get 0 equals 4. Oh, these 4s are killing me. W squared plus 56. W minus 85 and 8. 93. Okay. 4 is even, 56 is even, 93 is odd, no GCF. I'm going to have to look for, always see if there's a factor. 4 goes into 5 once, 16, 4. Okay, 16, so I can factor out a 2w from both of these. Let me think a second. Okay, so since these are really big numbers, if I did my beats method, I'd take 4 times 93 and make a really big number, 370 something. So I don't want to go that large. So I see a 4w squared would be the same as 2w quantity squared. So 2 squared is 4, w squared is 4, w squared, that's equal to that. Plus, and 2w, if I took a 2w here, then that would take out half of 56, which is 20. Let me think. 28. So 2w squared plus 28 times 2w minus 93. Okay, so now I want to take factors of negative 93 that add up to 28. And negative 93 would be negative 1 times 93 adds up to 92. Negative 3 times 31 adds up to 28. There it is. So 0 equals 2w minus 3 times 2w plus 31. All right, so w equals, now if I just move this 2 underneath this, so that would be opposite sign, so it's a positive 3 halves. Do the math if you have to. Set 2w minus 3 equal to 0, add 3, divide by 2, and you get 3 halves. Or w equals, move this 2 under the 31 and change it from positive to negative. We can't have a width of negative, so that's the extraneous solution. So my answer is 3 halves meters. 1.5 meters. Okay, number 5. Karen wants to plant a garden surrounded with decorative stone. She has enough stones to enclose a rectangular garden. There's our rectangular garden. With a perimeter of 68 feet. Okay. And she wants the garden to cover 240 square feet. That's area. What is the length and width of her garden? So, perimeter equals 2L plus 2W. Area equals length times width. We're told perimeter is 68, so I substitute in my given. 68 equals 2L plus 2W. Now we have two terms here, and they both have a common value in them, a factor of 2, so I can factor that out. So 68 equals 2 times L plus W. Okay? So now I want to divide both sides by 2, and I get 34 equals L plus W. Now we can either solve for L or we can solve for W. What is the length and width of her garden? It doesn't matter which we do. I could subtract L over, or I can subtract W over and solve for the other. I will just subtract L. So this would cancel, and I'm left with W equals 34 minus L. Okay. And she wants the garden to cover 240 square foot. So area is 240. And And length, we don't know. So I'm going to just leave that L. But now W is 34 minus L. This is a really tricky problem, but hopefully this makes sense to you. So now in terms of W, so what we're trying to do here is we're trying to get an equation in terms of one variable. We had two variables, L and W, but now we represent W in terms of L, so that W is gone and we have all this. So now 240 equals L times 34, which is 34L, minus L times L, or L squared. Okay, so this is a quadratic. And I don't like a negative squared value, so I'm going to move this stuff over to this side. So I'm going to add L squared, and I'm going to subtract 34L. And when I do that, add L squared minus 34L, then I get L squared minus 34L plus 240 equals 0. That is a 4, by the way. Keeps jumping and making it look like a 9. Same here. All right, so L squared minus 34L plus 240. Okay. So I'm going to look for factors of 240 that add up to negative 34. So since it's negative, it's going to be a negative times a negative. Negative 1 times negative 240 adds up to negative 241, too big. Negative 2 times a negative 120 adds up to 122. Negative 3 times a negative 80, that's 83. Negative 4 times 60 is 64. We're getting closer. Negative 5 times negative 48 adds up to 53. Keep going. Negative 6 times a negative 40 adds up to 46. Getting closer. 7 won't go. 8. Negative 8 times a negative 30 is a negative 38. Very close. We're looking for 34. Negative 10 times a negative 24 will give us a negative 34 sum. So there it is. So it's going to be L minus 10 times L minus 24 equals 0. Therefore, L equals 10 or L equals 24 when we do the zero product property. And you have to notice that both of these solutions are positive and could represent the length, because length and width are arbitrary directions here. The garden measures 24 feet by 10 feet, which is either quantity represented the width and the other representing the length. Okay. In other words, if the length is 10, the width is 24, and if the length were 24, the width was 10. So it's a 10 by 24 inch, or 10 by 24 foot garden. Okay, number 6 has to find two consecutive odd integers. Now remember, odd integers are 1, 3, 5, 7, ... on forever and ever and ever. So what do you have to do to get from, so if x is 1, what do I have to do to x to get 3? Well, I have to add 2. And what do I have to do to 3 to get to 5? Add 2. So consecutive odd integers would be x, comma, x plus 2, comma, x plus 4, comma, x plus 6. So if x is 1, this is 3, this is 5, this is 1 plus 6, which is 7. So hopefully that makes sense to you now. And so finding two consecutive odd integers whose product is 99, you would say x, product means times, so there's one odd integer, times consecutive x plus 2 equals 99. Distribute x squared plus 2x equals 99. Subtract 99 from both sides. When I do that, I get a quadratic of x squared plus 2x minus 99 equals 0. So now I'm looking for factors of 99 that add up to 2. So factors of negative 99 are negative 1, Actually, I want the bigger one. That's right. I want the bigger one, positive. Negative 1 times 99 is 98 when you add them. 2 won't go. Negative 3 times 33 is a difference of 30. 4 won't go. 5 won't go. 6 won't go. 7 won't go. 8 won't go. 9. Negative 9 times 11 is 99. And when I add these two up, I get 2. So x minus 9, x plus 11. So therefore, x has to equal 9, or x equals negative 11. Find two consecutive odd integers whose product is 99. There are two different pairs of odd integers. So if x is 9, x plus 2 is 11. So there's one pair of odd integers that adds up to 99. And the other one is negative 11. And when I plug negative 11 plus 2 in right here, I get negative 9. There's a consecutive odd integer of negative 11 times negative 9 is 99. Okay, here's a challenge. You have a 500-foot roll of chain link fence in a large field. You want to fence in a rectangular playground area. What are the dimensions of the largest such playground area you can enclose? What is the area of the playground? Okay, so before we look at this is a common problem on standardized testing, SAT, that kind of thing. This is a rectangle, very narrow, and if we have 500-foot roll of chain, let's just say that's 1 foot and that's 1 foot. So we've used up 2 feet, so now we're down to 498. So half of 498 is 249. Okay, 249, 250. So if I put 249 here, 249 here, 249 plus 249 is 498, 499, 500. So this would take up 500 square feet, or 500 feet of chain link fence, but the area is 249 times 1, or 249 square feet. Okay, but if I extend this out, and let's just make this 2 and this 2, this would be 248. And this would be 248. Because 248 plus 2 is 250, 250 and 250 is 500. So now this area is 248 times 2, which is 496. So this would be 496 feet squared. Obviously more, right? Now if I went to 10 here and here, that would leave 240 here and 240 here. 250, 250. So 240 times 10 is 2,400 feet squared. So I'm leading up to something here. The largest area we can ever make with a given perimeter, which is 500, is a square. Okay? Okay, so we have perimeter, and perimeter is 2L plus 2W. And our perimeter is 500. So 500 equals 2L plus 2W. All right? So if we divide everything by 2, 250 equals L plus W. And if I subtract L from both sides, 250 minus L equals W. Area equals length times width. So area equals L times W, which is 250 minus L. So now if I make a 0, and we have L times 250 minus L, well then we do the zero product property, so L equals 0 or L equals 250. So that means that the vertex of the equation is the vertex of the equation. In other words, this is a parabola, and the vertex is right here. And the vertex of the equation is L equals 125. Because if we have the length of 250 by 250, if we had that square, and this is 250, and that's 250, well, we wouldn't have this portion here. That's just two sides adding up to 500. We don't want that. We want a rectangle. So we'd have to, or a square, which is a rectangle. So we want to cut that in half so that they're all equal. So we want a square that is 250 divided by 2. So that's 125, 125, 125, and 125. Now there would be a shortcut to this problem with what I showed you earlier, with the rectangles becoming closer and closer and larger area values when you get to a square. And if you knew it was a square, you would just have taken this 500 and dividing it by 4. So it's a 125 by 125 square. So therefore the area equals length times width. So the area of this rectangular field, which is actually a square, is 15,625 feet squared. That is the end of lesson 7. Review the lesson summary and go to your problem set.